Today I'm going to be demonstrating how to repair busted Mac power supplies. If you look at this power supply, it's got a really bad case of a pretty typical problem. As it's bent over time, the outer shielding, which is fine wire mesh, gets thinner and thinner, and the insulation gets broken away to the point where it doesn't make enough electrical connection, and it overheats and melts and burns and gets really bad. I've trimmed away some of the plastic, but I'm going to do more of that. Before I get started, I want to talk about the tools and materials you're going to need. I have them arrayed in front of me. Scissors, razor knife, small needle nose pliers, wire cutter, little nippers that enable you to do fine trimming. I also find that tiny little scissors on a Swiss Army knife can be useful. Those are the tools. And then material. On the internet, on Amazon, I found this 1/8 inch copper foil tape that has a conductive adhesive backing on it. I'll post a link that shows where to order it. And then another key is this silicone tape. It's about 1 inch wide, and it's not adhesive, but it does stick to itself. And you use that for creating a flexible insulating cover around the repair. So the first order of business is to take the busted power supply and trim away a little bit of the wire or the insulation on either end so that you can make a repair and connect the insulation on this side to this side. So I'm going to trim about halfway back on the sleeve down here and a similar distance here. And I'm not going to make you watch that, so I'm going to pause the video while I work on that. Okay, that's done. Look, you can see the fine wire on either edge of where I cut back the insulation. You have to be really careful when you trim away the insulation that you don't cut the shielding wire, which is also the ground wire, because it's more like strands of steel wool than wire. It's very fine stranded wire. And if you can't really take a knife and cut along here, you have to trim with scissors. So that's done. The next step is going to be to cut a number of pieces of the foil tape, and I'm going to lay them across to the gap to make a connection. I'm going to wrap them in a slight spiral, so I want them a little longer than the gap. I'm going to cut these, let's see. It looks like the distance is about 1/2 inch, so I'm going to cut them to about 3/4 of an inch and then wrap them. So I'm going to cut a bunch of those, and again, you don't need to watch that, so stand by. Okay, I've got 5 pieces of foil tape cut to the similar length. I'm not sure exactly how many I'll need. I probably cut an extra. The next step is to take them, peel back the paper backing on them to expose the adhesive. And the foil is kind of fragile, so this is a little tricky. I have to fuss at it. You don't want to bend the corners any more than you can help it. And then wrap each one in a spiral pattern around the exposed outer wire. I found a spiral pattern does well because it's flexible, easy to get on, and it makes good contact. So there's one, and I'm going to wrap several more overlapping. Again, you don't need to watch that, so I'll do that and then start recording again when I'm done. Okay, and here's what it looks like. I did spirals, and then I wrapped a couple of strips of the foil tape in a circle around the top and the bottom of the splice to make really good contact, and then I sort of tighten it, tamp it down with my fingers. And then you have to judge how much of the silicone tape to put on. You want it to have a good grip on the beginning and end of the outer insulation so that it attaches here and attaches there. I'll also sometimes put silicone tub caulk on the end to make it adhere so that it doesn't slip off, and you want to pull this on really good and tight. This doesn't look to be long enough that this is a pretty big gap to go all the way across, so I think what I'll do is put a piece around the bare wire part and then another cut down to a smaller size, and then another full-size piece here and a full-size piece here to overlap. So I'm going to cut a piece size to go exactly across this gap, and then come back and show you wrapping it. Okay, here's a piece cut to the width I need to wrap just the exposed copper tape. And this is tricky because you want it to be pulled tight, but it doesn't stick, the silicone tape doesn't stick to anything but itself. So until it's stuck to itself, you really don't have any way to pull it tight. So you have to sort of squeeze it with your fingers and press it against itself. And once you've done that, put some tension on it and wrap it around itself. The tighter you get it, the better you repair. So you want to try and make it nice and snug. Okay, that's not bad. And then the next thing I'm going to do, as I said, is do a piece from the base of the power supply, one wrap, and then another one staggered a little bit the other direction because I want to get really good grip on both ends of the outer insulation. So, actually, you know what? I might be able to, I think I am going to instead cut it lengthwise and try and get a full revolution that way, because then I can do it to any length and I don't have to overlap. So, I lied. I'm going to cut one piece like this. Again, it's going to stick on the silicone, but it won't stick on either end, so I'm going to cut a piece of electrical tape, a couple of little tiny pieces of electrical tape, and use them to tack the silicone tape on to the beginning and end of the insulation. And you want to just put the smallest amount of the tape on, of the electrical tape on your silicone tape that you can, because the more surface of the silicone tape you cover, the less chance it has to stick to itself. And this will just enable me to wrap it tightly and hold it down better. It'll stick to the silicone tape. And now I hold it in place and start wrapping it around. Pressing it with my fingers so that I can get it to stick. And that's actually quite good. I'm pretty happy with that. The insulation on these power supplies is very soft, and any kind of abuse at all causes it to fail. If you look at this cord, actually this cord may not be worthy of salvaging. I'm just looking at it and it's a mess. It's split in more places than I can count. There, and it's got lots of splits here, and down here. I'm going to plug this in and make sure the repair worked, but I might have to call this one for the trash can, because I'm not sure I can protect that much of the insulation. One thing I might do is get a big piece of heat shrink tubing and cover the whole thing, or the whole part of it that's gone bad, which is pretty much all of it. But anyway, that demonstrates how you do the repair. This end I had repaired with heat shrink tubing. That doesn't actually work very well. When you put heat shrink tubing on it and then shrink it, it gets so stiff that when you bend the cable in using it, the heat shrink tubing doesn't have any give to it. It bends here, and you can see what happens. The insulation then splits. It splits there, and it fails again. If you look at the silicone repair, the silicone tape is very flexible. So when you bend it, it bends a nice smooth bend all along. There's no stress points, and it doesn't cause failure there or there. This one, I think I got it tightly enough wrapped that I'm not sure I need silicone tub caulk on the ends. And again, I think this power supply is hopeless, so I'm probably just going to throw it away. But if I were to keep this one as a repaired power supply, I might put a dab of silicone tub caulk along here. I might even try and pull the silicone tape up, put tub caulk under it and slide it down, or sometimes when I do a repair, I'll put just a little bit of tub caulk around the ends as I'm wrapping it, so the tub caulk is inside and forms a bond between the existing wire insulation and the new silicone tape insulation. So once the silicone tub caulk dries, it's good and stuck. And silicone tub caulk sticks to the silicone tape very well, and I buy the very fast curing silicone caulk. It's supposed to be dry to the touch in an hour, and you're not supposed to move it within, I think, 8 hours. So 8 hours later, 8 hours later, your power supply is ready to use. But that's a pretty good repair, and I dare say when I plug it in, unless one of these horrible messes is preventing it from working, or this end, which I had previously repaired with heat shrink tubing, is failed, it should work. I got a good bridge between the two ends. If you've got a new power supply, I suggest getting some of the silicone tape and simply wrapping one revolution around each end tightly. It's much easier to do if you don't have to cut back insulation, and if the existing insulation is a consistent thickness, do that there, and it offers much better strain relief, and you'll find your power supplies last a lot longer. So that's how you repair a Mac power supply. And by the way, iPod cables are made out of the same really poor quality wire with weak insulation that's subject to splitting open and failing. So the same strengthening on the ends is a good idea. They're cheaper and easier to repair, or easier to just replace. Unfortunately, these power supplies in the US are 85 bucks a piece, and the wire is not replaceable, so when they fail, you're out almost 100 bucks. I do not remember how many of these stupid things we've bought, probably at least 20. So we're into Apple for almost $2,000 worth of power supplies, which is absurd. There's 5 members of our family, and we are all Mac users. And some members of our family are harder on these than others, but they are not very sturdy, so they fail quite readily. So that's how you repair a Mac power supply.